Hi kids! Today we are going to talk about Avogadro's law. So I have three balloons, three different gases. I have oxygen, nitrogen, and hydrogen. They're all about the same size. So remember Avogadro? So we're going all the way back to stoichiometry. So Avogadro said that 1 mole of any gas at standard temperature and pressure. Mr. Veve, remember what standard temperature and pressure is?
Standard temperature is 0 Celsius or 273 Kelvin. Standard pressure is 1 atmosphere.
Okay, so make sure you're checking for that. If we're at standard temperature and pressure, 1 mole of any gas occupies the same volume, which is 22.4 liters, also on your reference chart. So I have 1 mole of nitrogen, 1 mole of oxygen, 1 mole of hydrogen. They have very different masses, but they will all occupy the same volume. Now I know these balloons aren't 22.4 liters, that'll be a huge balloon. But for comparison's sake, we know that they will all have the same volume because it's 1 mole. Easy enough?
All right, so after seeing that awesome video demonstration that you did with the balloons, let's talk about how to convert between liters and moles. Super simple conversion, still using those train tracks. So we know that 1 mole of any gas is equal to 22.4 liters, right?
At STP.
Oh, at STP, at Stony Point High School.
No, not really.
Not Stony Point High School?
Well, it is Stony Point High School.
Standard temperature and pressure, which we know is 0 degrees Celsius and
273 Kelvin and
1 atmosphere, 760 millimeters of mercury. You guys should know this. You should look it up if you don't. All right. So
okay, so if we have 2.33 moles of, let's say, nitrogen gas.
2.33 moles of nitrogen
at
gas.
STP, and I want to know the volume. Oh, we're setting up train tracks again.
How many liters is that at standard temperature and pressure? Let's set up train tracks. 2.33 moles of N2. I don't know how many liters that is, but I know that 1 mole of nitrogen gas is 22.4 liters. So if we multiply those two together,
then it's 52.2 liters. That's a lot of liters of nitrogen gas.
It sure is. But that was a pretty easy conversion. That's just another train track thing that we can use. What about going the other way? What if you give me liters?
What if we had 100 liters of gas and I wanted to know how many moles?
100 liters of just any gas. We want to know how many moles that is. And of course, this is all at standard temperature and pressure. This is the only reason we can use this conversion. Well, train tracks. 100 liters is how many moles? I don't know. But I know that 1 mole is 22.4 liters once again.
So we're dividing. 100
we're dividing
divided by 22.4 is 4.46 moles.
4.46 moles of whatever that gas was.
You may remember back from Stoke that anytime you're solving for moles, you divide.
Yeah, solve for moles, you divide. Solve for whatever the other thing is,
You
multiply. All right, seems pretty clear.